Let's look at another problem. A small university is concerned with monitoring its electricity usage in its student center. Specifically, its officials want to know if the amount of electricity used differs by the day of the week. They collected data for nearly a year, and the relevant summary statistics are provided. Note that electricity usage is measured in kilowatt hours. Okay, so state the appropriate null and alternative hypotheses for this test. Okay, notice that we've got 1, 2, 3, 4, 5, 6, 7 groups. So when we're writing our null and alternative hypotheses, now you could do mu1 equals mu2 equals mu3 equals mu4. You could do it like that. You could also do, so let's see, you could also do it with letters. You could do mu s, Sunday equals mu m, Monday equals mu t, Tuesday equals mu w, Wednesday equals mu r, Thursday equals mu f, Friday equals, maybe mu a for Saturday. You could do that. Or you could just say, well, this is going to be 1, 2, 3, 4, 5, 6, 7. So this would be mu1 equals mu2 equals mu3 equals mu4 equals mu5 equals mu6 equals mu7. And then the alternative would simply be the population means are not all equal. Okay, so now, are the conditions for ANOVA reasonably satisfied? Well, let's first look at the sample sizes. So here are all the sample sizes, and notice they're all greater than 30. So that condition is met. So we can say all n are greater than or equal to 30, so that's good. Let's say n sub I. And then remember, we need all of this standard deviations to be similar. So we have a problem if any one of these is about twice any one of the others. But do you see a situation where that has happened at all? So no, so we can say all the sample sizes are greater than 30 and all of the variabilities are approximately equal. So are the conditions met? Yes, the conditions are met. Okay, so the analysis of variance resulting from doing this test is in the table below. Use the F distribution to find the p-value for this test. So we've got our test statistic. So F statistic equals 6.547. And then remember, our degrees of freedom of the numerator is right here, the 6. And our degrees of freedom of the denominator are 306. So what are we going to do on our calculator? We will go FCDF 6.547, E99, 6, and 306. So let's do that. Second distribution, get to FCDF, and we're going to do 6.547, E99, and then I need to use the degrees of freedom. This should be 6, and this should be 306. And look, I'm getting a super small value again. So 1.6124305405. Remember, that means move the decimal 3 places to the left. I mean 6 places to the left. So that'd be 1, 2, 3, 4, 5, 1, 6, 1, 2, 4, 3, 0, 5, 4, 5. which if I round to 3 decimal places is just 0. So my p-value is 0.000. Now with that p-value, what is my decision going to be? Well, 0.000 compared to 0.05 is much less than that, which means I will reject the null, and we can say there is evidence to conclude the mean amount of electricity used, electricity used differs by day of the week. Okay, and let's look at one last problem. Breakfast is often considered to be the most important meal of the day. Data on the number of calories per serving for randomly selected cereals from 3 different brands are summarized in the provided plot and the table. State the appropriate null and alternative hypotheses for testing if the mean calories per serving differs among the 3 brands. So again, remember, if we only had 2 brands, we could use all of our strategies from section 6.4 and just test 2 means. But we've got more than 2 brands, so we need to use ANOVA. So here we could say mu1 equals mu2 equals mu3 is our null hypothesis, and our alternative would just be that the population means are not all equal. Oops. So are the conditions for ANOVA reasonably satisfied? Let's go look here. Well, we're a little concerned. So, oops, not all n's are greater than or equal to 30. So that's a problem. Let's look at the measures of variability. The measures of variability are reasonably equal. So this part's a problem, so maybe not. We can say the variabilities are all somewhat equal. So that part's fine. But sure would be better if we knew that all the sample sizes were greater than or equal to 30, or that we knew that the populations were reasonably normally distributed. So here's the computer output for the ANOVA. And again, now this is a different software, and there are many different softwares that can be used to do statistical analysis. So this, notice how this output doesn't exactly look the same as this output does here because it's a different software. But you can still see that the general format and placement of the values is the same. So here's your F statistic. Here's your p-value. So we can report the F statistic is 7.92. The p-value is already given to me, so I won't have to find it. It's 0.001. So now we can start making our conclusion about the test. 0.001 is, again, less than 0.05. So my decision here would be to reject the null. And then what's my conclusion in context? It would be, there is evidence that the mean calories per serving differs among the 3 brands. And that's it. That's all we need to know for ANOVA. And that is our last section. Try not to celebrate too much.